So in an earlier lesson, we looked at factoring simple trinomials. Today we're going to look at factoring complex trinomials. So what's the difference between a simple and a complex trinomial? Basically, where the coefficient on that leading term, that a value, does not equal 1. So we know that quadratic expressions have the standard form ax squared plus bx plus c, where a, b, and c are just numbers. We have been working up until now where this a value is equal to 1. So things like we have right here, where a would equal 1. And we want to be able to take a quadratic and go from this standard form that we see right here to a factored form. So we want to be able to write this as something times something else. And we've developed a method for doing this for simple trinomials. We know that the first term in each bracket has to be an x, because that's going to get us this x squared that we have right here. And then we find two numbers that multiply to our last number, which in this case is positive 7, and add up to our middle number, which is negative 8. So the numbers here would be negative 1 and negative, not negative 8, but negative 7. And those two numbers are the last terms in each of our brackets. So this would be x minus 1, x minus 7. Now, what happens, can we use this same method if our a value is not 1? What if we have something like 8x squared plus 10x plus 3? Well, we could start off trying to do this the same way. We could say, okay, I'm going to write this as the product of two things. What do I need to get this first term, 8x squared? Well, I definitely need an x here and an x here, but I'm going to need some coefficients on that x to get that coefficient of 8. I could put a 2 and a 4 there, but there are a bunch of other possibilities. It could be negative 2x and negative 4x. It could be 8x and 1x. It could be negative 8x and negative 1x, and so on and so on. So just like all along, we've had choices for what the two numbers are that multiply to give us the final number. Now we have to figure out what combination of terms is going to multiply to give us our first number. Okay. Now, there is a method of doing this that avoids kind of all of this confusion here, and it makes use of a pattern that we can notice if we go back and we do some expanding of binomials. So we want to end up in something that has a factored form like this. So what if we start from this factored form and expand and get our trinomial and see what happens? So let's just do our FOIL here. 4x times 2x, 8x squared, 4x times 1, 4x, 3 times 2x, 6x, 3 times 1 is 3, and then we know that we can collect together that 4x and that 6x to give us 10x for that middle term. All right, so what patterns can we see in this? Well, I want to focus in on these two middle numbers right here, this 4 and this 6 that we've ended up with after doing our expansion. Right? These two numbers add to positive 10. And they multiply to, let's see, 4 times 6, positive 24. Now, how are those numbers, that 10 and that positive 10 and that positive 24, connected to our trinomial? Well, we know that in our final form here, this is our b value. So the positive 10 is our b. So we're looking, those two numbers add up to give us our value for b. What about this 24? Well, if I look at my value for a and my value for c, a times c is 8 times 3, positive 24. Okay. So focusing on these two numbers, this 4 and this 6, these middle numbers here, give us something that's going to add up to b and multiply to this value of ac, which suggests there's a relationship between our values of a, b, and c and these two middle numbers here. So let's just see if this holds true by doing a second one here. I've got 2x minus 2 times x plus 5. Again, I'm going to do my FOIL here. 3x squared, 3x times 5 is 15x. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And I collect those two middle terms together. 3x squared plus 13x minus 10. All right, what are our values of a, b, and c? A is 3, b is 13, c is negative 10. And if we focus in on these two middle numbers, 15 and negative 2, these two numbers, again, they add to 15 minus 2 is 13, which again is our value of b. And again, they multiply to, let's see, negative 2 times 15 is negative 30. But if we do a times c, that's 3 times negative 10 is negative 30. So once again, those two middle numbers add up to b and multiply to ac. So we can use this relationship to kind of work backwards and develop a method for factoring our trinomials. So here's how this method is going to work. This is called decomposition. It's also known as the AC method because we use this relationship between the numbers we're looking for and a times c. But here's how it works. We look at our trinomial here. We identify our values of a, b, and c. So a is 4, b is 8, c is 3. And these are all positive. All right, find a times c. So a times c is 4 times 3, positive 12. We want to find two numbers that multiply to AC, so multiply to positive 12, and add up to that middle number, b. Now, from our previous work in factoring, we've gotten pretty good at figuring out what these numbers are that multiply to something and add to something else. So two numbers that add to 8 and multiply to positive 12 are going to be 2 and 6, and these both have to be positive here. What are we going to do with this 2 and this 6? We are going to use these two numbers, this 2 and this 6, to break up that middle term. So we're going to take this 8x here, and we're going to write it as, instead of writing it as 8x, so we'll have a 4x squared, we're going to have a positive 2x and a positive 6x. So we're replacing the 8x with plus 2x and plus 6x, and we're keeping the last two terms the same. So we've used those two numbers that we found to write this as 4 terms instead of as 3 terms. What are we going to do next? Well, now we can factor this thing by grouping. So to factor by grouping, we're going to group the first two terms together and the second two terms together. And we're going to look first at the first two terms, and we're going to see what's common. A 2 is common, and an x is common. And then we've got to think about, okay, what do I need in these brackets? So 2x times what gives me 4x squared? I'm going to need a 2x. And then 2x times what gives me 2x? Just a 1. And then I'm going to look at my second two terms. And what is common between my 6x and my 3? Well, both are divisible by 3. There isn't an x term common to both of them. So what's going to go in the brackets here? 3 times what gives me 6x? 3 times 2x gives me 6x. And 3 times 1 gives me 3. Now I notice that the 2x plus 1 and the 2x plus 1, the 2x plus 1 is common to both of my terms, so I can factor that out. 2x plus 1, and I'm left with the 2x plus 3. 2x plus 1 times 2x gives me 2x times 2x plus 1. 2x plus 1 times 3 gives me 3 times 2x plus 1. And there we have our trinomial in our factored form. So the key was figuring out these two numbers breaking this thing up or decomposing that middle term into two separate terms, and then we could factor by grouping, a factoring strategy that we've already practiced. So let's take a look at a second one here. 3x squared minus 5x minus 2. Our first step here is going to figure out, okay, what is a times c? So a is 3, c is negative 2, so that's negative 6. We want two numbers that multiply to that negative 6 and add up to our b value, that middle term, which is negative 5. And we're going to use those two numbers to break up that middle term. So let's figure out our numbers first here. Multiply to negative 6 and add to negative 5. I think I need a 1 and a 6, and I think that one has to be negative, and I think that one has to be positive. Let's see, 1 times negative 6 is negative 6, and 1 minus 6 is negative 5. Okay, so we're going to use those two numbers to take this negative 5x, and we are going to write it as plus 1x minus 6x, okay, breaking up that middle term. Okay, and now let's do our factoring by grouping. So our first terms here, what is common? Looks like the only thing that's common is the x. So 3x plus 1. What about our second two terms? What is common between those two? Well, they both have a negative sign, so I'm going to factor out something that is negative. Okay, and what is common to the 6 and the 2? Both of them are divisible by 2, so I'm going to factor out a 2. What am I going to be left with? A 3x here. Negative 2 times 3x gives me negative 6x. And a positive 1 here. Negative 2 times 1 gives me negative 2. And again, we can now see that the 3x plus 1 is common to those two terms. So we factor out the 3x plus 1, and we're left with x minus 2. Okay. We got a couple more here that we can do together, and then I'll give you one to try on your own. And I might just give myself a little bit more room here. So the steps should start to be familiar by now. So if I want to do, let's just show those steps here. If I want 8x squared minus 10x minus 3 is what I'm trying to factor here, I'm going to start by figuring out a times c. 8 times negative 3 is negative 24. So I want two numbers that multiply to negative 24 and add to that middle term, negative 10. I think these numbers are going to be a 2 and a 12. We'll do 12 and 2, and one of them has to be negative and one of them has to be positive. I think this is negative, and this one is positive. Positive 2. So we use those two numbers to break up our middle term here. 8x squared minus 12x plus 2x minus 3. Group our first two terms together. What is common between those first two terms? We're going to look at both the numbers and the variables. For our numbers, 8 and 12 are both divisible by 4. We've got an x squared and an x, so we can factor out an x as the lowest power. That's going to leave us with a 2x and a negative 3. Say 4x times negative 3 gives me negative 12x. 4x times 2x gives me 8x squared. In our second term here, we're looking at, our second factoring by grouping, we're looking at positive 2x and negative 3. What's common between those two? There's nothing really that's common. So all we're going to do is we're going to say, well, the only thing we could factor out is a 1. This is like 1 times 2x minus 3. And we do that to highlight that now we have a 2x minus 3 that is common to these two terms. So if we factor out the 2x minus 3, we're left with 4x plus 1. All right, let's look at one more together, and then we'll get you to try one on your own here. I got 6x squared plus 19x plus 15. Okay, first off, a times c is 6 times 15. 6 times 15 is going to be 90. And I'm going to put down positive 90 because the positive sign kind of matters. Then I want two numbers that are multiplied to that positive 90 and add to that middle term, that 19, positive 19. Well, this is actually kind of easy. This is positive 9 and positive 10. So we're going to use those two numbers to break up that 19x. 6x squared plus 9x plus 10x plus 15. And then we can factor by grouping what's common to our 6x squared and our 9x. Well, both are divisible by 3. 6 is divisible by 3 and 9 is divisible by 3. And x is common to those two terms. So we're going to be left with a 2x. 3x times 2x gives me the 6x squared. 3x times 3 gives me the 9x. In our second pair, if I look at the numbers are both divisible by 5. There isn't an x common to both of them, so I will just have, let's see, to get 10x, I need to 5 times 2x, and to get 15, I need to do 5 times 3. And sure enough, the 2x plus 3 is now common, so I can factor out 2x plus 3, 3x, and I'm left with the 3x plus 5. Okay. All right, so you should be ready to try one on your own here before you go off and do the practice questions on page E3. Pause the video, try this one following the steps that are listed right there, and then start the video and check to see how you did. All right, so a times c is going to be 2 times 12, which is 24. So we need two numbers that multiply to AC, so multiply to that 24, and add up to positive 11. What are those two numbers going to be? They're going to be positive 8 and positive 3. So we're using them to replace that 11 there, so I'll use plus 8x plus 3x, and then we have our plus 12. Now we can factor by grouping what's common between our numbers. Both 2 and 8 are divisible by 2. I see an x squared and an x, so an x is common. Then I'm going to have an x plus 4 inside here. 2x times x gives me 2x squared. 2x times 4 gives me 8x. In our next two terms, 3x and 12, both of them are divisible by 3. 3 times x is 3x. 3 times 4 is 12. The x plus 4 is common, so x plus 4. And what's left over? 2x plus 3. And there we have our factored form.